Before we go any further, let's take a look at what the Minimax algorithm actually does. The Minimax algorithm is a recursive algorithm used for finding the optimal move for the player. There's an assumption under the Minimax algorithm that the opponent will always make the optimal and rational move that counter yours or move them towards a victory. One person is considered the maximizer and the other is the minimizer. That means that one person, the AI, is assumed to be maximizing their score, while the other is assumed to be countering that effort by minimizing the score. Since in tic-tac-toe there is pretty much a win-lose proposition, and it's a very simple game, the score in this case will either be 1, that's max, or -1 is minimum. The maximizer, or the AI, is working towards 1, or victory, while the minimizer is picking moves that ideally result in them winning on the maximizer losing. They usually work towards -1. Now then, let's visualize the Minimax algorithm using an example. Here, O is the minimizer and X is the maximizer. It is currently O's turn to move. At the very top, we see the scenario. O here has 3 choices to make. He could place his stone on the middle left, he could place his piece on the bottom center, and he could place his piece on the middle right. In the first scenario, he can place it in the middle left. This will allow X to play in the remaining 2 scenarios, namely bottom center or center right. When X plays center right, on the 5th scenario here, as you can see, O is able to win because now he has the opportunity to connect 3 stones together in a row. So then, this will minimize his score since O is the minimizer, right? He wants to minimize X's possibilities to win. Therefore, if O wins, then X will lose, and therefore X's score will be minimized by O. Tracing back to the scenario again. If X decides to block O's chance of connecting 3 in a row vertically, then O can simply connect horizontally 3 of his pieces by placing his stone on the center right. This also minimizes X's score. Moving back to the second scenario. Here, if it's O's turn and O decides to place his stone in the center the center bottom, then essentially O would already have a 3 in a row. In this case, O has already won the game, and therefore O has minimized X's score. In the third scenario, figure 4 here, if O decides to place his stone to the right, then in this case, O loses, because X is given the chance to essentially connect 3 on the left. Essentially, this maximizes the score because X is the maximizer. So in all 3 of these scenarios, O has analyzed all possible playouts of the 3 choices that O has. O in this case would not pick scenario 4 because it knows that would lead to X be able to connect 3 pieces in a row. On the other hand, O would be most likely to pick scenario 2 or scenario 3, as they both result in a win for O and minimizing the score. That's just a brief introduction to the Minimax algorithm and how my algorithm actually works to create an AI engine that plays tic-tac-toe.